Let us now analyze the vertical asymptotes of a rational function. The question here is, consider the rational function x plus a times x minus b divided by x minus c times x minus d. Will this function always have two vertical asymptotes, one at x equals to c and the other at x equals to d? Explain your answer. So that is a very simple and straightforward question. I've seen most of the students will say yes. Well, at x equals to c and x equals to d, we do have a discontinuity. Denominator becomes 0, right? But will that always lead to vertical asymptote? What is your suggestion? This is what we want to understand. Now, those of you who say, well, both will lead to vertical asymptotes are slightly wrong. There could be situations where both of them or one of them may not lead to vertical asymptote. Can you tell me what is that situation? So let me give you a hint here. When can you get a hole in this situation? So what is the possibility of getting a hole from this kind of an expression? That is the real answer for this question. You can get a hole in such a rational function if you have common factor in numerator and denominator. Do you understand? Then you have a hole. You don't have a vertical asymptote, right? For example, if I make b equals to c, for example, then how the expression will be? Expression will be x plus a times x minus c divided by x minus c times x minus d, right? In that case, x minus c cancels out, and so here we have hole. Do you understand? So in this case we have hole at x equals to c. Do you see that? Not a vertical asymptote, right? Similarly, if I make b as d, if I make b equals to d, in that case I'll have hole at this point at x equals to d. Do you understand? So there are so many situations where this function may result into not two vertical asymptotes. Different options are there. So what are the different options? So the different options are, all the different options, let me list them out for you. So one of them is, of course, two vertical asymptotes. One of them, not always, right? And the other two is, can you tell me now? So we can have one vertical asymptote. Let me write one vertical asymptote and one hole, right? And the other could be two holes. No vertical asymptote at all. Do you see that? So all these are possible in this scenario. So you can get two holes provided if a equals to minus c, this factor will cancel out, correct? And if b equals to d, the other factor will also cancel out. Do you get the point, right? It becomes a constant function, 1, do you understand? In that case, with two holes, one at c and one at d. If we have one common factor, then we'll have one hole. If we have two common factors in numerators and denominators, then we get two holes. But if we don't have any common factor in numerator and denominator, then we get two vertical asymptotes, correct? So that is how we have to see this, right? And of course, this function has a restriction, and that is x is not equal to c or d. Is it okay? So that restriction applies whether it has a hole or it has a vertical asymptote. But the important thing which I want to get across is that there is a possibility of having two vertical asymptotes, a possibility of having one vertical asymptote and one hole, and also a possibility of having two holes, right? Now as an exercise, provide some values of a, b, c, d so that you get two holes and then sketch your function, okay? That is an exercise for you. Thank you and all the best.